Welcome to my classroom. In this video, we're going to be talking about part 3, the data analysis part of your mealworm investigation. You are to collect data from the rest of the class using the information from trial 2 of your mealworm distance traveled. In the table below, you see the groups, the fraction of the table traveled by each mealworm, and the length of the table. In part 1, you have a quite difficult task of now ordering the fractions of the table traveled by each of the mealworms from greatest to least. Then explain how you ordered the information. You can use words, diagrams, or equivalent fractions to help explain. Now, in real-world math, fractions aren't going to be as pretty as you see in a math textbook when you can simply make these common denominators in order to compare. We have a lot of fractions to compare here. And you have even more in the actual investigation. We're going to need to order all of these fractions now from greatest to least. If you look at all of this information, you're going to see we have with denominators like 5, 33, another 5, 10, 31, and 12, it's going to be very difficult to find a denominator that all of these fractions have in common, especially the 31 and the 33. And you can think, what are 5 and 10 and 31 and 33 and 12 all going to have in common? That's going to be a tough task to start figuring that out. So I would suggest to think about it logically and sort the information into two groups. So then you're not trying to organize all of it. Those two groups can be over 1/2 and I'll put the over 1/2 down here, and under 1/2. That will help to start beginning to sort this information. So now if we look, okay, 7/12, let's compare that to a half. I know a half, if we had 7/14 would be a half, or 6 out of 12. If our table is 12 inches, or 12 centimeters, and the mealworm travels 7 centimeters, it traveled over a half. So I'm going to put 7/12 down here. I can tell that is over a half. Now if we look at our next piece of information, 4/31, I can tell that's way under a half. I know like 15, if the table is 30 centimeters, 15 would be half of that. So 4, even though it's 31, it's going to be way under. So I'm going to put that one up here. Next is 3/10. We also know that 3/10 is going to be under a half because 5/10 would be a half. 5 out of 10 would be 1/2 of the table. 4/5. Okay, I can think if our denominator is 5, or our whole table is 5 centimeters, 2.5 or 2.5 would be a half. So if he went 4 out of 5, that is quite a bit more than a half. So I'm going to put 4/5 down here. That's over a half. 8/33, same thing, I could tell that is under a half. And now we can go to 1/5. Once again, we know that 2.5 was a half. So 1/5 would be under a half. Already we've now made this an easier problem because now we know what our two biggest numbers are, that they are over a half. And we now have 4 numbers that are under a half, and we can begin to either find common denominators or use our understanding of fractions to make a conclusion. Even if we don't have the exact evidence, we can support it. So 31 and 33 are quite similar in denominators. I believe that we can compare them even without making the denominators the exact same. Both of these have denominators of about 30. So maybe let's take our other fractions now, this 3/10, and if we were to get it to a point we could compare 3 out of 10 to get it to a denominator of 30, we would be multiplying. If we have a table length of 10 centimeters, to get out of 30, it's like multiplying by 3. So we're going to multiply each side by 3, and whatever you do to one side, you must do to the rest. So that is going to equal 9/30. So I'm actually going to erase this part, and I'm just going to write, I'm going to call this 3/10, 9/30. They are equivalent. They're moving in the exact same ratio. And same thing, if I wanted to get this fifth out of 30, if my table is 5 centimeters, to get out of 30, it's like I'm making it 6 times bigger. So whatever I do to the denominator, I must do to the numerator as well. So this is like 6/30. Now we can begin to compare. And if I'm going to look for the smallest here, okay, even though in this problem here, 4 out of 31 is going to be, this denominator is bigger than 30. And so that's like saying we have a bigger table, and our mealworm traveled even a lesser distance of the bigger table. And what I mean by that, and this is where it comes into a tough concept, because if this was 4 out of 30, 4 out of 30 would still be smaller than 9 out of 30, or 6 out of 30, obviously. But this is even smaller than 4 out of 30. It's 4 out of 31. And 4 parts out of 31 is even less value than 4 parts out of 30. So I'm getting a feeling that this is my smallest right here. Even though we have a bigger table here, 33, the mealworm travels twice as much. So if I'm ordering these, I'm going to start saying this is like my smallest. And now I have these left. Okay, 6 out of 30, 9 out of 30, or 8 out of 33. Well, if this was 8 out of 30, we can kind of just think about that as 8 out of 30, and it's not, it's 8 out of 33, but if it was 8 out of 30, it would be bigger than 6 out of 30 and smaller than 9 out of 30. So I can kind of use that reasoning. Now I know this has a bigger denominator than the 6 out of 30 because it's really 8 out of 33, but we're saying if we made our table was only 3 centimeters bigger, that means the mealworm in just that 3 centimeters of difference would have traveled 2 centimeters further. That's still quite a bit. So I can kind of use my inference to say 8 out of 33 is going to be larger than 6 out of 30. So I'm going to put this 6 out of 30 next, but I'm going to really put it as 1 out of 5. And then I'm going to go with my 8 out of 33. It was not 8 out of 30. And then I'm going to say this was my next biggest. And now I can compare these two at the bottom. 4/5 or 7/12. You might be able to just infer it, which one is bigger. But if we want to make them common denominators, they both go into 60. So to get 12 into 60, it's times 5. So this is like 35 out of 60. Or to get 5 out of 60, the denominator, it's like times 12. So 12, 24, 36, 48. So it's like 48 out of 60. So we can see this one's definitely bigger. So we're going to put it like this. Of course, the problem asked us to order them from greatest to least. So if we go from greatest to least, we're going to have to reverse the order and say that this value was the most, this was the second most, this was the third most, fourth most, fifth most, and sixth most. And if we use our calculator, we can kind of see the value of the fraction. The value of the fraction is, what would it be represented as a decimal? So 4 divided by 5 as a decimal would be like 0.8. And that's what that fraction sign means. It really means like divide. So that's another way we could see it. 7 divided by 12, oops. 7 divided by 12 is like 0.58. Excuse the handwriting. 9 divided by 30 is like 0.3. So we can see in decimal form, it's a little simpler to see that we are getting smaller. 8 divided by 33 is 0.24, 0.242. 1 divided by 5 is 0.2. And let's see what 4 divided by 31 is. is 0.12. So we can see by looking at it kind of with a calculator and getting in decimal form that we are correct. I wouldn't want you to do it with a calculator. I want you to organize the fractions first and express your understanding of that. The second part of this says to add a part of the table and now find what that value represents. So if we added a column in this table, we would be doing it like this, and now find out what does this value represent. I'm just going to delete my writing over here. So the worm traveled, in this case, 7/12 of the table, and the table was 48 centimeters. So I can make a tape diagram for this. That's one strategy I could use. And in this case, the whole table was 48 centimeters. So I would label this 48. And it traveled 7/12. So I would now have to divide this up into 12 parts. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm just kind of doing it with my mouse so you can see that's not a very good job doing the parts. And I would label 7 of the parts. 1, 2, 3, 4, 5, 6, 7. I could shade in those parts. And I would label this traveled. And you don't need to do this for every one. Once you kind of get the hang of it, you can realize, okay, I'm doing 48. I'm dividing it by 12. And then I need to multiply it by 7. So when I do 48 divided by 12, that means that each part is 4. I can use black. So each of these parts are 4, and it went 7 parts. So that means when I'm writing what is the value of the fraction, okay, the fraction is 7/12, but it ultimately has a value, and that value is expressed as the distance in this case that the mealworm traveled. And in this case, the mealworm traveled 28 centimeters. So I took 48, I had to divide it into 12 pieces, and I took 7. 48 divided by 12 is 4, times 7 is 28. For the next one, and I'm just going to go through each one of these, because what I'm interested in is this order going to be the same when we find the value of the fraction. Okay, 93, I'm going to take 93 divided into 31 pieces. Well, 93 divided by 31 is 3. So I'm getting 3 times bigger, and I'm going to take 4 of those pieces, so that is 12 centimeters. The next one, 60 divided into 10 pieces, means each piece is 6, times 3 is 18 centimeters. In this part, now we have 50 centimeters divided into 5 parts. Each part is 10, times 4 is 40 centimeters. Over here, we have 66 divided by 33, so that's 2. And it traveled 8 pieces, so that's 16 centimeters. And then down here, 60 divided by 5 is 12, so we just have 1, so it went 12 centimeters. So now if you're going to organize these from greatest to least, let's see if the order is the same. We would have 40 centimeters is the most, so in this case that's still 4/5. Next we would have 28 centimeters, so that's still 7/12. We have 9. Next we have 18. And that 18 centimeters actually corresponds to that 3/10. Oh, I accidentally wrote 9/30. That is 3/10. I should have written that at the beginning. Next, we have 16 centimeters, and that does correspond to this. Next is 1/5. Oh, and there's actually a tie here. What will be interesting to see is if when you organize your fractions from greatest to least, you get the same order when you organize the value of the fraction from greatest to least. Because if you had a worm that traveled 40 centimeters, if this one was at a really big table, let's say this was at a table that was 120 centimeters, It still might have traveled the furthest distance, but the fraction might not be the greatest. So that's the work for part 3 in this investigation. Hopefully this video helped you out.